Okay, in this problem we have a block, and the block is there is a horizontal force applied on the block, and the block has a mass of 5.4 kilograms and has an initial velocity. It's going up, and the force, this force of 50 newtons that is horizontal, is applied on the block. You're given the coefficient of kinetic friction, which is 0.3, and it has an initial velocity of 4 meters per second. So we are asked to find the magnitude of the acceleration, whether it's going up or down, whether it is how far is it going to go, and then when it reaches the highest point, does it remain at rest or slides back down? So let's look at how to do this problem. So the first step, remember, we always work with these three steps. We prepare, then write Newton's equations, then solve, and then do algebra and find what you want to find, and then finally you assess. So let's start with preparing. So the first thing is we need to identify the object. The object is that block there, and then what are the forces? Well, we have the force F. We are going to have a normal force. We are going to have the weight, and we are going to have the friction. Any other forces? No, I don't think so. So that's good enough. So now let's draw a free body diagram. That's part of preparing. So identify the forces, and then you draw a free body diagram. So for this, we want to have a coordinate system for this free body diagram where the acceleration is in the x-axis. So we are going to choose a coordinate system that is tilted. So let's just draw that. So this is my y-axis and my x-axis, x and y. And this here is my angle theta. That is my angle theta, and this is my object here, right there. So now let's look at the forces. So we have the weight, that's the weight there. We're going to have the force applied to the object, that is F, and this is theta here, right? This is theta, this is theta, and that is theta. It's good to always make sure you know which angles, what is the angle that you need to use. So now let's draw the normal force. It is this force here, that is the normal force. And you are told that this is sliding up, so it's going up in that direction with an initial velocity v0. So therefore the friction has to oppose that, so the friction points down. So this is the friction here. It points down. Okay, so we have our free body diagram. So now we are ready to write the equations. So let's start with equations for the y-axis. And in the y-axis, we have the y component of the normal plus the y component of the weight plus the y component of that force. And that has to be equal to 0 because there's no motion in the y-axis. So now let's do the x-axis. And in the x-axis, you have the x component of that force, that applied force, and then you have the x component of the friction, and then you have the x component of the weight, and that is equal to mass times the acceleration in the x-axis. So those are the two equations. Let's just go back to this equation a little bit. This is also mass times the acceleration in the y-axis, but the acceleration in the y-axis is 0 because there's no motion there. So therefore, this is equal to 0. So now I have the two equations. So let's just figure out what these components are. We have these vector components for all the forces. Let's start with the y component of the weight. So the y component of the weight is this one here. So it would be this force, this component here. So that is the y component of the weight, and that will be W cosine theta, which is equal to mg cosine theta. Let's do now the y component, the x component of the weight. And the x component of the weight would be this guy here, right? So that guy there. So that is w sine theta. And that is a negative. That has a negative. This one here was negative. I forgot to say that. So this is negative because it's pointing in the negative y-axis. And this is also negative because it's pointing in the negative x-axis. So this is also minus mg sine theta. So we have the components of the weight. So let's find the components of the force. The force has two components. The x-axis, that is a positive force, and is F. And then it'll be this component here, right? And that component is what? Is F cosine theta, sorry. F cosine theta, right? And then the y component is also a component that points down this direction there, and that is F sine theta, but that is negative because it points down. So I have the components of the weight and the components of the force. So now the next thing we want to do is we want to find the friction. The friction is this force here, and remember the friction force is what is just the friction coefficient times the normal. Okay, so we have all the forces. So now we want to find the acceleration. So the acceleration is given by this equation here, right? So the x equation. So let's just write that down. So the acceleration then would be what? The acceleration is equal to, well, F cosine theta, right? So Fx, which is F cosine theta, plus the friction force, which is mu times the normal, and this is going to be negative, right? So this is going to be negative because it points down. And then we have the weight in the x direction, and that also is negative, right? So it's minus mg sine theta. And all this divided by m. So that is the acceleration. So we could find that, we can find this number here, F cosine theta, we can find this number here, but we need to find the normal force to find the acceleration. To find the normal force, we are going to use then this equation here, right? So the equation in the y-axis, we are going to use that equation to find the normal force. And that equation reads like this. So the normal force then is equal to minus this plus minus this. And so that'll be the normal force then is equal to mg cosine theta, that is the y component of the weight, and then you would have plus F sine theta, that is the y component of that force there. So then we can go ahead and now put this normal force here, and then we can write the acceleration as F cosine theta minus mu, and then you get mg cosine theta plus F sine theta, and then you're going to get that this is minus mg sine theta, and all this divided by m. So now from here it's just a question of putting in the numbers, right? So I've done this previously, so I'm going to just write them down. So this is a sub x is equal to 39.9 newtons, that is this number here, F cosine theta, minus 0.3, then you get 42.3 newtons plus 30, so that is this number and this number, and then you get minus 31.9 newtons. And in all this, I use the fact that theta is 37 degrees, right? So then all this divided by 5.4. So now I can do this math, and hopefully I did this little algebra right, and I get that a sub x is equal to minus 2.53 meters per second squared. So then I have the acceleration, the magnitude of the acceleration. Then, because it has only one component, I can say right away that it's 2.53 meters per second squared. That was the first question. Magnitude of the acceleration. The direction of the acceleration, well, is negative. So the acceleration is actually going down. So the acceleration in this object, and let me erase this here. So the acceleration points down. So that is the acceleration there. So when I'm going to answer D first. So when it reaches the highest point, does it remain at rest or it slides back down? Well, the acceleration is pointing down, so when it reaches the highest point, it's going to slide back down because there is an acceleration pointing down. So I can answer D right away. And finally, how far does it go? Well, for that, we need to use a kinematic equation. So we have the acceleration. So let's assume that started from 0. So the distance that goes up is going to be equal to, well, it's going to be equal to, so I have, let's just write the kinematics equations that I could use to remind ourselves. So we have that, we could have that x final is equal to x initial plus v0x delta t minus 1/2 plus 1/2 a delta t squared. That is one equation that I can use, and the other equation is bf, the final square is equal to the initial square plus 2 times a delta x. So this is what I want, delta x. So this second equation seems to be the most appropriate. So the final velocity when it reaches the top is 0. So then I can write that delta x is equal to v0 squared divided by 2a, and here so this is negative and this is negative, so the two negative cancel out. So I get that this is 4 meters per second, that's the initial velocity squared, divided by 2 times 2.53, and that is equal to 16 divided by roughly 5. So let me just do that quickly here in the calculator. So 16 divided by 2.53, that is equal to 6 divided by, oh, I need to divide again, 2.53. So that is equal to, it is roughly equal to 2.5 meters. So that's as far as it goes. Okay, so this is the problem. So this is a nice problem, and I think it has all the ingredients for a typical problem. If you are comfortable doing a problem like this, then you should be okay for the exam.